Okay, class, now we can come to the third part. We call it catapult. Okay, catapult. Okay, we call it catapult. If you refer to your textbook or your reference book, the arrangement is actually it first come with what is electromagnet, right? Electromagnet is temporary magnet when current flow through conductor. And second part in your textbook or reference book is actually catapult. Okay, and then third part of it is actually induced EMF. Okay, induced EMF. That is the arrangement. Electromagnet, when there is current flow through, it has magnet, right? Okay, induced EMF is when you have permanent magnet. Okay, you cut through it, you produce current, right? So catapult is actually combination of these two. Then you get force. Okay, so that's why I actually rearrange the thing. I will teach electromagnet first, induce EMF, then only catapult. So what is catapult? Catapult, we need current, and then we need magnet. So now we combine. This is, let's say, permanent magnet, North Pole to South Pole. You see that it is from North Pole to South Pole. And then I have a wire. The wire, just now we cut it through, right, in induced EMF, but now I connect it to current. So there is current flowing through. So you know that then when there is current flowing through, you have magnet, right? And then this electromagnet will interact with the permanent magnetic field, and then it will produce a force. That force is what we call catapult force. Okay, so now look at here. This is in your notes. Okay, class, you look at this one. Okay, so the first one with permanent magnet. So it always come out from North Pole to South Pole. The second one is, you imagine that you have one wire like that. It come out from, so it is dot, right? Means that it come out lah. If it is cross, it is going in. So you imagine that you have your current that coming out. Right hand grip, if you still remember right hand grip. So the magnetic field line is actually anti-clockwise. So when you combine this one and this one together, so what happened? You will see that this one going this area and this one going this area, which means that it actually weaken each other, right? Because this one in pointing to the right, this one pointing to the left, so it will cancel out each other. It become weaker. While this part, the lower part, you see that the current, the electromagnet flowing in this direction, permanent magnet also flowing in this direction, it will become stronger. So in exam, when you draw the line, you have to draw more line at the bottom and less light above. As a result, the stronger will push the weaker. So it will cause a rotation effect, which we need it in motor. Okay, like fan. Okay, why is it fan can turn? Because we have electromagnet and permanent magnet. Okay, I would like to show you the, this is a pair of force. Okay, you see that we have a magnetic field line pointing towards South Pole, and then the current. For this one, there is current, right? We are going to use Fleming left-hand rules. Fleming left-hand rules. Okay, look at this part. Fleming left-hand rules. Fleming left-hand rules are, this is current. This one will point towards South Pole. So we position middle finger first. Middle finger, look at DC. And then your pointer have to point towards South Pole. Okay, you see that? So the force is actually acting downward. Okay, so when the force is acting downward, it will cause, this side will acting upward. So it actually cause a rotation effect. So it will move the whole coil. That is what we call DC motor. Okay, we have two types of motor, either DC or AC, but the effect will is still the same, that we need a pair of force and it make it turning. So this chapter, this subtopic, comparatively is easier. If you compare to electromagnet and induced EMF, it is easier, much easier. You just read through my notes, and then you can see that it is everywhere in our daily life. Okay, loudspeaker, we have this also. Okay, so in reality, we use radial. This is what we call, do you see the magnet shape? We call it radial magnet, cylindrical magnet, because it can produce a more concentrate electromagnetic force, concentrate magnetic field. Okay, so it can actually produce stronger catapult force. Okay, And then what is the factor affecting catapult force? What is the factor affecting catapult force? Still the same like just now. The strength of the magnet, and then of course the wire, the current, and also the area that covered. Okay, so that's all for catapult force. It is easier if you understand what is electromagnet and what is EMF. Okay, now come back to this thing. Okay, so overall what you have to know is what is electromagnet. When there is current, there is magnet. What is induced EMF? When you disturb magnet, you produce electric current. So what is catapult? When you combine permanent magnet South pole and North pole, with current carrying conductor, it will produce a force. So catapult is a force. Yeah, yesterday Alistair actually mentioned about what is that, Plant versus Zombie, the game. Okay, there's one catapult force, that's something that pulling and then it throw the cabbage over and so on. Yes, that is catapult force. Catapult force normally it will move like that lah. Okay, so catapult force, if you play the games then you understand what I'm talking about. Okay, so that's all for the 1, 2, 3 part, and then we have actually 2 more part behind. That is transformer and also the efficiency and so on and blah blah blah. Okay, that's all. Thank you, class.